All right, so here we go. We are changing things up on you, right? We're going kind of backwards. If I tell you the zeros in the beginning, if I give you the zeros and ask you to write the polynomial that gives you those zeros, can you do it? Okay, that's the question. I'm going to show you an example and then we'll do one together. Okay? First of all, you have to ask yourself, if 1, -3, and 4 are the zeros, then what were the factors that go with those zeros? Right? What factors give you those zeros? That's the question. And the answer is
12.
x minus 1 times x plus 3 times what?
X minus 4.
X minus 4. Write that down. Those are your three factors that gave you those three roots. They're nice, they're not fractions, they're real numbers. Easy peasy. Now all you got to do is do what? Multiply those together. And the idea is that you're going to multiply these two and then multiply x minus 1 times whatever you get. You're going to have to FOIL, you're going to have to remember Math 1 all the way back to Math 1 when we did this with polynomials. If I FOIL this out, I get x squared minus x minus 12. Okay, just trust me, that's what you get if you FOIL, F-O-I-L, first outside, inside, last. Now we have a binomial times a trinomial. How do we multiply a binomial times a trinomial? Do you remember? Big word, starts with a D. Distribute. We got to take the x and multiply it 3 times, then we got to take -1 and multiply it 3 times. So I get x cubed minus x squared minus 12x. Right? I distributed my x all the way across. Then what do I have to distribute? I have to distribute -1 all the way across. So I say negative x squared, positive x, and positive 12. See how I stacked my like terms? X cubed, x squared, x, and no x. That makes it very easy to do this last step. What's my last step here? Combining like terms. I'm combining like terms. So I get x cubed minus 2x squared minus 11x plus 12. And this polynomial gives you those three roots. If I give you the roots, what do you have to be able to do? Go backwards and tell me what the polynomial is that gives you those three roots. Okay, questions? All right, I got one more monkey to throw in here and then we'll be done. Why? What if your zeros were 2 and 3i?
Well, there has to be a -3.
That's exactly right. Say that again.
There has to be a -3.
If they only gave you 2 and 3i, you have to be smart enough to say, no, no, no. Those aren't all the roots. There is another root of -3i. If 3i is a root, the conjugate of that, -3i, also has to be the root. So then, how would we set that up? What are the factors now? X what? X minus 2. That's the easy one. Then what do we do here? X minus 3i and what?
X plus 3i.
X plus 3i. Do you remember how to do that? It's been a long time since we FOILed complex numbers. Calculator won't do it for you. You want me to show you?
Please.
Okay. Everybody's eyes up here and watch. X times x is x squared. X times positive 3i is plus 3ix. 3i times negative 3i times x is negative 3ix. What's going to happen to those? Thank goodness they go away. So they're not even really important. But then the important one is negative 3i times positive 3i. And you get negative 9i squared. But if you remember, if you go way back and remember I squared, what does I squared equal? -1. So watch. You scratch that out and that 9 becomes what? Positive. So all of this is just x squared plus 9. And doesn't that make sense? If you move the 9 over and square rooted it, what would you get? Positive 3i and negative 3i. So that kind of should kind of ring a bell there. This is still times x minus 2. So then we have to FOIL that out just like regular. We get x cubed minus 2x squared plus 9x minus 18. I wrote it in standard form, and that's the polynomial that gives you the roots of 2 and 3i and negative 3i. Okay? How could you check that this gives you this? Mode 54 would give you these three roots. Okay? Questions? Any questions? Say that again. Now we're going to practice together.